Right, so before we start, I would really like for you to go and grab yourself a pen and paper. If you can grab one really quickly, I should have said that earlier, shouldn't I, really, while we're waiting. If you want to join in, I'm not going to cold call people and make them join in if they don't want to, but definitely if you would like to take part, if you want to write anything down today, or if you want to do some of the working out, then you'll need a pen and paper to do that, or a pencil and paper, whatever works for you. Okay, so while you're getting one, I'm just going to move on to the next slide. So we're going to talk about 3 separate sections today in our Maths CPD. Part 1, we're going to look at the foundation of number. So looking at the EYFS curriculum, learning through play is so important. All of these acronyms, the EYFS is the early years foundation stage. Development matters are the things that the children need to know by the end of the foundation stage. So before they move into primary school at the end of reception. There are 2 early learning goals in maths that I'm going to talk you through today that the children need to be able to meet. But we're thinking about what does that look like in reception. And then reception parents, feel free if you'd like to leave at that point. You don't need to listen to the rest of it. But it's really helpful for even year 6 parents to hear where the knowledge of number comes from. So it's really important kind of to start with that foundation basis for everybody. But feel free, if your child is in year 2, for example, then you can leave after the next section. So part 2 is all about what does it look like in year 1 and year 2. So we also call that key stage 1. How do we introduce the children to the mathematical concepts that they have started to learn about in reception? And then we're going to look at that embedded with what that looks like in key stage 2. So moving up from year 3 up to year 6. What I've done is I've kind of embedded it in. So for year 2, I've kind of skipped between year 2 and year 6, because actually a lot of the concepts that we teach children are established in year 1 and 2. And it sounds mad, but hopefully as I'm going through, you'll be able to see exactly what I mean and what that needs to look like. As I said, any questions that you have, please feel free to pop your questions into the chat, or you can ask me at the end on the chat, and I'll try my best to answer them. Okay, right, so what does number look like in UFS? So there are 2 separate strands that I'm going to talk about, but they're both learned through things that you would expect in UIFS, learning through play, learning through songs, through games, through teacher questioning, asking how many more, how many less. All of everything they do, it's called continuous provision in reception. And we want to get the children to initiate their own learning of maths. So they might go over to a table and there's some bears on the table. And they're not just talking about the color of the bears, but they're also talking about how many bears there are. And if there are 4 bears, if there's 1 bear more, how many bears would they have in total? And it's kind of like that early understanding of what number needs to look like comes in all the way to when the children start, really when they start nursery, or even when you're at home. I can imagine, you know, when with your little ones, you're kind of embedding maths all the time, talking about number, you're thinking about, you know, trains, when you're on the bus, all that sort of thing, kind of gets those concepts and those mathematical foundations ready. So there are 2 separate strands that we teach towards the end of the early learning goals for reception. So the first strand we're going to talk about is number. Okay, so number is a development of a number sense. So our expectation is all of our children can leave reception being able to count from 1 up to 20, to know that the numbers are all in order, they're sequenced, and the idea that we count them once. We want to teach our children how to say what's 1 more than something, what's 1 more less than something. And that's usually with a set. It could be pointing to, I don't know, having the bears example from earlier, 4 bears and 1 more than 4 is 5. Or it could be knowing that if I've got a sequence, 1, 2, 3, 4, that 5 comes next. And they're both kind of the numerical and the concrete basis. Both of them we need to expose the children to in reception. So when they're able to count reliably and order the numbers, then we introduce the idea of addition and subtraction and the idea of more and less. So if I have 2 bears and I get 3 bears more, how many bears do I have altogether? How many do I have in total? And writing those really simple number sentences is where the foundation stage starts. They also need to be able to, this idea of kind of estimation and checking. So if I know I've got 4 bears and I'm going to have 3 bears more, in total I have 7 bears, but let's count the bears and let's check. And that's really, really key, because it's the idea of one-to-one correspondence, that you can't count the same bear once, more than once, so you can't count the same bear twice, I should say, and the fact that you can count the bears in any order and the total is still the same. That's so, so important to get that foundation of number sense. And then we move on to problem solving. So thinking about doubling, if I had double as many bears, halving, if I share them, is the beginning of division that they start to learn in Key Stage 1 as well. So they have lots of kind of development of their idea of what a number is. So thinking about it in a set, and I'm thinking about it also as a numeral. as a number that we would say, or in Key Stage 1, what it looks like as a digit. So as well as number, running alongside that, we also have another development matters strand called shape, space, and measure. So shape, space, and measure is all about vocabulary, and it's vocabulary linking to mathematical kind of knowledge. So it could be things to do with comparing quantities of size, weight, capacity, position, distance, time, money. It's kind of all of those other things that are really key to maths, but aren't just number based. So you might be thinking about, I don't know, how much would it cost if I bought this? Or do you think the Xbox or the bear is more expensive? It's kind of building in that language. Also thinking about size is so important. The fact that if you have a larger bear, it's not more of them, there's still one. So you could have a small bear and a large bear, but they are the same. They're still one bear, but it's the fact that size, often children think, oh, there's more because it's bigger, and it's kind of developing and reducing those misconceptions. Creating patterns comes under this strand, which is really important, and thinking about everyday objects and shapes and using that language. So this is a square or a rectangle, and they might play some songs. I remember the shape song when I was in reception. It's still in my head now, of the different shapes that we want the children to learn. But it's kind of all that kind of vocabulary and description that comes around mathematical terms, as well as developing a number sense that I've mentioned earlier. So that's kind of where we are at the very beginning. So how do we do that within school? Well, we use anything that can be counted, basically. So we use lots and lots of equipment within schools. We use Numicon. So Numicon on the right-hand side of my screen here, you can see here I've got the numerals 1, 2, 3, 4, 5, 6, 7, 8, 9. And next to them, I have these weird kind of little, I don't know what really how I would describe them. They're like little plastic things with holes in. And these are called Numicon, and they are wonderful objects because they always make 10. So if I have a look at these ones here, I can see that I've got the, for example, 5 and 5, and they fit together with the little nodules to make 10. Or I've got 7, and then the 3, the little nodule here, the yellow one and the pink one, they fit together to make 10. And Numicon is how we teach lots and lots of things in Key Stage 1. And in EYFS as well. But that's a good resource that we use, and children may come home and talk about Numicon, and that's what they're talking about. We also use Unifix cubes. Now, Unifix cubes are these kind of cubes that are first on the left. They're like the tall ones that can be broken up into chunks. And they're really vital, because it means that children then can recognize, I have 3, but I put 3 together and 3 can make a set. And then I can add 4. So I've got 3 plus 4 makes 7, not 1 plus 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 1 equals 7. So it helps them to make different types of sets when they're in reception. And we also have Cuisenaire rods, or Cuisenaire rods, I'm not too sure how to say it, which are next to the Unifix cubes, also really colourful for the EYFS children. And they can't be broken up. So they are in specific chunks. And you can see there that the 10 rod and is the same size as the 9 rod plus the 1 rod. So that's kind of how they fit together as well. We have bead strings, which I haven't got a picture of. Basically, they're beads on a string. It's fairly self-explanatory, but that's really good for adding how many more, adding them to a set. Counters, number lines. You can see here on this picture at the bottom, I've got bears and, I don't know, I think they're like some sort of dinosaurs, pens. Also thinking about body parts. Really great. We have kind of a base 10 approach with 10 fingers. 10 fingers are so incredible when it comes to the reception, making number ones to 10 as well. So we need to recognize that anything can be counted whatsoever. And there's the idea there of one-to-one correspondence. So behind that is the idea that you can only count something once. So if I'm counting to 5 and I'm going to count these 5 bears here at the top of my 5 picture, I know that I've got a green bear and a yellow bear and another green bear and 2 blue, and together they make 5. And I'm not going to start from, I could start from the middle, the yellow bear perhaps, or the green bear. And as long as I've counted them all once, I still only have 5. Also, the idea of cardinality is so important. And I've written there the 5-ness of 5. They need to know that 5 can be represented in lots and lots of different ways. So in the middle on the whiteboard there, we have the numeral of 5. Then we've got 5 pens, we've got 5 Numicon, we've got 5 as another kind of a 3D numeral here. And it's really important that children understand that that is 5. And this bottom one, substitutizing, that's how I say it, substitutizing, is the idea that sometimes you don't even need to count. So underneath on my kind of like domino shape at the bottom here, I know that's 3 and 4, and I don't need to count them by going 1, 2, 3, and 4, because I'm able to substitutize. And that's something that is really key in reception. that we want all of our children to be able to count and to be able to know that that's 3 and that's 4, and on my picture I have 5. Okay, so that's kind of how we develop the understanding of maths, through games, through asking lots of questions, through interpretive play from the children. We want them to really get involved with kind of being exposed to number. Okay, right, so how can you help from home if you are a reception parent? I'm not going to read all this out for you because all of this will be available on the website afterwards, but it's just questions. You may not have, fancy Nemicon and Cuisinart rods at home. You don't need them. You just need some spoons. And thinking about how many spoons you have and how many more spoons you would need to make 10. But brilliant to ask questions. And the bottom one here, vocabulary. Building in those words, that kind of mathematical language is so key in those early years of development. Here I've got a picture on the right hand side of the Alamo houses in San Francisco, and I've used this even in my year 6 lessons for what shapes can you see, taking the children out and seeing in the house what can you see, or outside what do you notice, where are my circles, where are my squares, what do you notice about the size of that triangle compared to the size of a triangle in somewhere else in the picture. And kind of exposing the children to that language is so key, because it helps to build their own understanding and their sense of number, which is really integral to when they move into Key Stage 1. Okay, so that really was a whistle-stop tour of EYFS, and hopefully if I've got any EYFS practitioners, I've taught down there, but not for a long while, so I'm happy to come back with anything that isn't quite right or anything that I've missed off for sure. Okay, so what does this look like in year 1 and 2? So when we move into year 1, we use lots and lots of concrete resources. So I was showing you just before, about gummy bears and cubes, and we still have those. They have their place in Key Stage 1, but we're also using lots more kind of mathematical kind of objects, really, less about playing, more about kind of understanding and the reasoning behind it. In my year 1 class, I always used to let them play for the first 2 minutes of a maths lesson, because they would want to stack up the deans. These are called deans, these purple things on the right hand side, and see how many. Or when we're teaching in tens and we have straws, they want to bend the straws. So it's kind of giving them that mathematical ownership over the fact that actually now we're moving into maths resources. Okay, so some examples here of some things that we've used in our Key Stage 1 classes. So as I've said, these purple things, they're called deans. And we have 10 little deans, which are the little cubes, go together to make one long stick of deans, which is a 10 stick of deans. And this is really crucial for addition and subtraction. Children need to understand that I can have 1 10, which is one stick, or I can have 10 ones, and they're exactly the same. And when the children kind of understand that, if I look at this left picture here, they know that in the number 13, I have a digit 1 and a digit 3. The 3 is worth 3 ones, and there they are. The 1 is worth 1 10. And that's really key. We would never call this 1 in the tens column, because it's 10. It's 10 ones, and it's 1 10. And when the children understand that in that clear place value, when they move through into year further up school, into year 2, year 3, etc., they are really able to articulate what it means to be a 10 or 100 or a million, because they know the worth of that number. Also down here as well, we've moved into the kind of the third picture along, we've moved into the pictorial. So now we've moved them off the deans. They don't need the physical resources, but they can draw it. And that's really important. And we'll talk to you about that why in a moment. Other resources we use in Key Stage 1 that are really vital. We use these unifix cubes in things called 10 frames. So we've moved away from unicorn, kind of fixed numbers. Oh my goodness, the puppy is destroying something. Eek. Never mind. So they're using 10 frames, and they know that they've got 10 in a set. So this might be 15 plus 4 by the looks of it. So they know they've got 1 10, and then they've got 9 ones. And also within this, sorry, I've just got some more people in my waiting room. We move them onto counters as well. So here we have counters as well, 10 frames. So you can see here that the child is writing out a number sentence and using counters to support that. So the idea that they've got, I don't know what it is, 15 plus 4 or 5, I think it's 5 this time. And what does that look like? And it's moving them through from the concrete, from the things, to the pictorial drawing of things, and then into the abstract. So what do the numbers tell us? What do the numbers mean? And they need a solid understanding of number and place value for that to happen. So maths in year 1 and 2 is when we introduce our math scheme called effective maths. And effective maths is absolutely fantastic, because it really embeds those number concepts and that number fluency that we start to begin in reception. We focus on skip counting, times tables, 2, 3, 5s and 10s, knowing them in and out, being able to count, 3, 6, 9, but also knowing that if you've got 2 plus 3 makes 5 plus 3 makes 8, and being able to skip count in that way is so, so important. Number bonds to 10, oh my goodness me, if you can teach them 7 plus 3 make 10, 6 and 4 make 10, playing, some ping pong games with them, their mathematical knowledge, even when they go as far up, in year 6. I have my year 6 children last year in bottom set maths, counting on their fingers. If I've got, 7 and I'm going to take away 3, they're putting it in their head and counting backwards. And if they just knew, well, if I've got 7, I'm minusing 3, 7 and 3, I've got 4 in my number triangle, my number bonds to 7 are really secure. And if they know that, that's really, really important. Also, number bonds to 20, really key. If I say 19, you say 1. If I say 14, you say 6, and making them so they have those numbers in their head as pairs. They're called number bonds. Also thinking about number bonds to 100 is so, so key as well. Even up in year 6, working with finding percentages of amounts, knowing that if I've got, 25%, I've got 75%, and looking at the mixtures between them. And this all starts in Key Stage 1. It starts with that secure understanding of what number is and the fact that we have a base 10 approach to number. And we also have our maths toolkit, so looking at procedural fluency. So I know it's quite small here, but this is what they would look at stage 2, which is year 2. By the end of the year, we would want them to do all of these things. And you might say that's not very much. You don't need them to do many things. We don't, but we need them to do these things so, so well and be able to do it with complete fluency, with 2 or 3 second recall is kind of where we're up to. We would really like, if I say 7, they say 3, being able to add numbers 14 plus 8, knowing I'm going to have to bridge to the next 10. So I could add 6 and then add 2. And if they're able to articulate that now in Key Stage 1, then when they move up the school, it makes our job so, so much easier. Times tables a little bit further down at the bottom, knowing times tables for 2s, knowing division facts for 2s and 10s as well. I think this might be year 1 actually rather than year 2 by the looks of it. Bridging units are something that Effective Maths have brought in to make sure that children are able to catch up the work they missed in lockdown. So that's really, really key. So it's looking back at what we did before and plugging those gaps, because we know that there are knowledge gaps throughout kind of all of their learning because they had a significant amount of time off. So that's something else that Effective Maths have done really well. I'm a massive advocate for Effective Maths. The only bad thing about it is everything is copyrighted. So I've had to make all my own stuff today. And what they do is they put the videos on a website, and it's like a movie. And so it makes it really difficult. You can't like take off their PowerPoints and adapt them for your own. We can't send them home. But there is a website that I'll show at the end that has some parent resources, but I'm afraid we have to just work with what we've got with Effective Maths. It's a wonderful resource, but he doesn't want it to be trademarked and copied across. Okay, so why do we focus so heavily with number? So you would have noticed on the maths toolkit that I just spoke you through, a lot of it is number-based. And this is the reason why. Most of we don't want to talk about SATs and it being the be all and end all, but actually, we need to get these children ready for the Key Stage 2 curriculum, which means they need to be really fluent in 2 separate strands of learning. So their arithmetic, so can they solve simple sums like 8 plus 7, 9 plus 20, 200 plus 9? Can they then reason, I have 9 sweets and I get 17 more, how many sweets do I have altogether? And you will see that even in the reasoning paper, 36% of that is still calculation based. So it's still looking at addition, subtraction, multiplication and division. And 72% is calculation based in the arithmetic paper. So it's looking at your 4 operations. So addition, subtraction, multiplication and division are so, so key. I'll also touch a tiny little bit on fractions today. But if you'll have a look here, you would think a lot of what we teach in maths at school must be about shape. Actually, it's not. So geometry is 3% position, so looking at angles and turns in Key Stage 1, I should say, not angles. Looking at shape, so 13% is looking at shapes. 19% is looking at measure, number and place value, and only 3% is looking at graphs. Lots of people kind of have that misconception that maths is all about, squares and triangles. Actually, it's not. The majority of it is procedural fluency for calculations. Can the children add, subtract, multiply, divide? Can they find fractions? And the rest of it, we kind of cram in here and there. We do a week on time here and there, but then time is linked to division. So everything is all kind of linked together. Okay, right. So what strategies do we teach for calculation? It's really important that children know what the question asks of them. It sounds ridiculous, but if it's worded in a reasoning problem, I have some sweets, I get 9 more. How many do I have altogether? It's knowing what the operation is for that question. How many different ways can you say it? So addition, we say plus, we say add, we say total, we say amount. And it's making that vocabulary really accessible to the children. In class, we all have vocabulary displays, and we try and vary our language as much as we can. But if you're kind of you always use the same word at home, we're going to do 7 add 6, then thinking about if you said 7 plus 6, or even something as simple as putting the equals first. So blank equals 9 plus 4, then that can really help as well, because you were thinking about the different ways that we can say the different 4 operations. They need to be really, really fluent with the operations and the methods they could choose to answer them. Today, we're going to talk about some different methods that the children can use, and there's not a right or a wrong. The great thing about effective maths is it teaches you 4, 5, 6 methods, and then the children get to choose their favorite, which actually works out really, really well. And we also have lots of resources to support learning in school, lots of displays, 100 squares, number lines, number fans, equipment. But at home, you don't really need that because we've taught them the concrete basis in school. So hopefully when they're coming home to you, they can say, oh, I've learnt this. I could use my cubes, but actually I'm going to show you using my numbers and see whether they can do it that way. Definitely, if you feel like you would like to have some resources to support learning at home, if you feel like my child would really benefit from having 100 square, please ring up reception, let them send an email to the class teacher, because it would be brilliant if that, we could provide those resources. Same as times table 100 squares. I know some year 6 classes sent their children home with them. They're just so integral, and your teachers, the Garrard teachers, would be so grateful if you did want any of those resources. Of course, we could point you in the right direction, or maybe even supply them for you. Okay, so calculation strategy. So here we are, we're a year 2 child. These are questions taken from the 2017 SATs paper. So I've given it a basis. If you want to use SATs papers to practice, please do, feel free, but don't use the recent ones because we use them to moderate. And your child may learn the questions and come out and you think, oh my goodness, my child's a genius. And then we think they're a genius in school, and it comes to the actual test, they might struggle if they've already seen the questions before. So I've used an old paper. If you would like to do the same, that would be really, really helpful. Okay, so traditional ways to do this. So even when I started teaching all those years ago, I would have said, okay, 5 plus 7, we're going to put the biggest number in our heads and we're going to count on our fingers. And that's something that effective maths has completely debugged for me, because they would say, well, that's not a very time efficient strategy. They would say that's a very error prone strategy. I could count one finger more than once. I could put the wrong number in my head. I could do 5 and then forget that I'm going to add 7. So they teach us lots of other different strategies using concrete concepts that the children know. So for 5 plus 7, they would know, well, 7 is made up of lots of different number complements, because I, in year 1, learned my number bonds to 7. So it could be made up of 6 and 1, or 5 and 2, or 4 and 3. So I'm thinking that if I'm going to add 5 plus something to get to the next 10, I'm going to break my 7 into 5 and 2. So I know that 5 and 5 make 10, and 2 more makes 12. And that would be a really kind of efficient way to be able to count on to the next 10 and then bridge the next 10. And that's one of the strategies we would teach. To give you another example, if we did, for example, 6 plus, sorry, I'm having to write these down to think about it. 6 plus 5, well, I know that 5 can be 5 and 0, and 4 and 1, and 3 and 2. If I've got 6 and I want to make the next 10, I've got 6 goes with 4, add 1 more would give me 11. And it's having that really secure knowledge of number so the children can make those decisions. They might even know by practicing this strategy, 7 plus 5 makes 12. And that's what we would want for our year 2 children, to be able to look at that and think, I don't even need to add my fingers. I don't need to go to a number line, because they're able to do that with so much confidence, because the secure number facts are there, because they've gone over and over the same things. For number 2, 19 take away 9. Well, I know that 9 is nearly 10. And if I do 19 take away 10, that gives me 9. I'm going to add 1 because I've added 1. So then my answer would be 10. So it's kind of always thinking about what the children know. Do they need to put that in their head and count on their fingers? Not necessarily, because they might even recognize there that I've got 9 ones in my ones column and I'm taking away 9 ones. So therefore I'm going to have 10 left. And they might be able to do that without even thinking about using kind of their fingers or a written strategy for that. Okay, so what does this look like? Also thinking here, so we've got number 2, so third question, 87 take away 40. So if the children are really confident with the fact that in 40, I have 4 10s and no 1s, and if I look at my number, I've got 87. So 87, my 7 1s is going to stay the same because I've got 0 1s in, it's so much easier to do this if you were here. I've got 0 1s in my 1s column. So I'm going to 7 take away 0 is going to stay the same. So I'm going to have 7. Now I've got 8 10s take away 4 10s. Well, that's easy. 8 10s take away 4 10s is 4 10s. So my answer is 47. So without putting it into a written method, the children are able to look at the numbers and think, right, what can I solve from this? And what do I need to work out? They like to trick you out with ones like this in the bottom. So they always like to put their missing box. It's either at the beginning, in the middle, or traditionally at the end. But when the children see something like this, often they think, oh my goodness, I might need to add. They might think that they need to, oh, we've seen all sorts. We could get 70 in here. We could get 30, which is the right answer. We could get all sorts. So the main thing to remember, if the box is in a different place in a question, you're always thinking, where is the biggest number? So the operation is subtraction. In subtraction, the largest number comes first, and that's really, really key. So if I know I've already got my biggest number, I'm going to have to take away. If, for example, my box came first and I had box take away 50 equals 20, well, my subtraction still stays the same, but I'm going to have to add, because in subtraction, the largest number comes first. So they might do 50, well, they would do 50 plus 20, which would give them 70. So 70 take away 50 equals 20. And it's the same with addition. If you ever see an addition missing box, we're always thinking, where is the largest number? Well, the largest number in addition comes after the equals. So if the box comes first, for example, it's box plus 30 equals 50. I'm going to try and hold it up on my screen, but you can't see it. But box plus 30 equals 50. I know I'm going to have to take away, because if I added 30 and 50, I would get 80, and that's too many. And it is kind of that reliance on estimation that is introduced in reception, that idea of checking, that will be so, so valuable for the children. To know that if I did have, for example, in this example, if I had 70 in that box, could that be correct? No, it couldn't, because in subtraction, the largest number comes first, and it's always using that vocabulary with the children is really, really helpful. Okay, right, so this can be applied all the way up. So now we're going to skip. Imagine you are a year 6 parent or a year 6 child. This is a question that you'll get in your arithmetic paper, but the skills are exactly the same. So, but now I'm looking at my numbers that are slightly bigger. So I've got 979. So in that number, I've got 900s. I'm going to add 100 more. If I've got 900s plus 100, I'm going to have 10 hundreds and 79, which is 1079. And that vocabulary of understanding what each digit's worth is so, so important. Okay, so I'm just going to go through that one, or another one. No, actually, I'm not going to, because I can't show you. If I had a whiteboard and I was able to model it, but if I go through and I have to try and share my screen, I'm going to do it a little bit later to model something. It gets into a little bit of a nightmare. But we're thinking about how many hundreds do we have? If I was going to add, for example, that one, I could do 979. If I was going to add 10, then I wouldn't be looking at my hundreds column. I'd be looking at my tens column. My 1 stays the same, my 100 stays the same. I'm adding 1 more 10. 1 more than 7 10s is 8 10s. And we're having that really concrete understanding, so the children don't then go away and put it into a column method, because they don't need to, because they know what the facts are for that number if I'm adding 100 more or 10 more. This is also lifted from an old Key Stage 2 SATs paper. It's exactly the same. It's taking away 9. I'm going to take away 10. I'm going to add 1. And it's exactly the same. Or I might notice that I've got 2 1s and I've got 9 1s that I'm taking away. So 9 can be broken into 2 and 7. So I'm going to take away 2 and then take away 7, which gives me 4, 6, 3. And being able to work those out without having to put it on their fingers is such a key skill that's relevant all the way across, just with slightly larger numbers. That's the only way they challenge them. Or this one, slightly different. We don't teach decimals until we get into year 4. But if the children know that I've got 6.1, 6 is in my ones column, my decimal point is sitting above, and I've got one of those things called tenths, and I'm going to add 3 tenths. Well, I've got 1/10 plus 3/10, which gives me 4/10, and my 6th one stays the same, which gives me 6.4. And the children are really able to answer that really easily because they can recognize that actually I don't need to bridge. I don't need to put this into a written method. I can find the answer, and it's quick and it's fluent, and they can check because they have that really concrete understanding of number. Okay, hopefully that wasn't too quick. Okay, right, but you're saying those are really easy. What about further through the Key Stage 1 SATs paper? So what strategies do we teach for addition? Here, this is a little bit more tricky, and it's more challenging because we've got our 3 1s and our 8 1s make more than 10. So we're putting them back into the concrete to start off with. We're going back to our deans, and the children are making 43 in one pile, and their partner makes 38 in the other pile. And then they put them all together and they count the ones first, and they think, right, I've got 11 ones in my ones pile, and I can't have 11 ones. So my 10 ones becomes 110. I've got 1 1 left, and then I've got my 8 10s. So they're being able to exchange 10 ones for 110. That's really, really key. In the concrete, understanding I can't have 11 in my ones column. I can't have 2 digits in one column. So where is it going to go? And once the children kind of have understood that I can't have 11 ones in my ones column, then we move them on to the method on the right-hand side here, which is the pictorial method. So here I'm showing them exactly the same sum, but in a different way. I've got 4 10s and 3 1s, and I've got 3 10s and 8 1s. And they're looking at the ones column and thinking, I can't have 11. It doesn't fit. My 2 digits can't go into one column. So I have 1 10 and I have 1 1. And that's where my 11 comes from. So now I'm looking at my 10s. Well, I've got my 3 10s at the bottom and my 4 10s. That's going to make my 7 10s plus 1 more 10. That's where my 8 10s is going to come from. But the children have to understand that this is 10 ones, because otherwise they might get 811. That might be a common misconception. So we have the digits 811. They might completely forget about this 110 altogether, or they might put the 1 in the wrong place. They might mix the digits up. So it's that secure understanding of place value is so, so important. Okay, once they've understood it pictorially, then we move them on to the numbers. So here the numbers work in exactly the same way. So I've got my 3 plus 8 ones, which gives me 11 ones. I've got 4 10s plus 3 10s plus 1 10, which gives me 8 10s. And it does sound laborious for saying 10s every time and hundreds, but it's so, so important that we don't call this 4 and 3 and 1, because it's not. That 4 is worth 4 10s or 4 T1s, and that's really, really key for the children to understand. And the reason why it's key is because look at what it looks like in Key Stage 2. So here I have got my addition sum. This is lifted from a Year 6 paper, and it's exactly the same skills as what we've just looked at. But now I'm going from my 1s to my 10s to my hundreds and to my thousands, and all of these digits are really key. So I always start with my 1s column first. I've got 4 1s plus 6 1s, which gives me my 10 1s. 10 1s is the same as 110, which is why I've got a 1 in my 10s column. And this 0 here is so important. It's my placeholder. It's holding my digits in place. It's important the 1 doesn't go here, because then that would be 1 1, but I have 10 of those things called 1s. Then I've got 3 10s plus 8 10s, which gives me up here 11 10s, plus 1 more 10 gives me 12 10s. 12 10s is the same as 12 T, or 120. And the children get really used to using that language and using that vocabulary. And then I've got 0 hundreds plus 500s plus 100, which gives me my 600s. And then I have my 1000. And that is the language that we would use when we're explaining this. And it does seem wordy. And maybe when they get to Year 6, you could drop it, especially when you're going into long division and you're talking about, regrouping in your thousands. It makes it very, very difficult. But at this point, it's so, so important that we're using that vocabulary, and the children will be encouraged or value headings when they see a question like this in their test, just so they don't get confused, and so they're able to lay it out in this way. When you were at school, you may have put the 1s above. The reason why we put them underneath is just so you can really clearly see that you're adding the top section before your big equals, and then you add what's been exchanged. So we call this our big equals. So we're adding the top part first before the bottom part, and it's just to help break it down for the children. And when we would model on the board, I would literally use my finger. I do 4 plus 6, and I point to the 4 1s and the plus sign and the 6 ones, so the children are able to count really, really carefully. Okay, right. That was a whistle-stop tour of addition. It doesn't really get that much more complicated than that. They can have more digits, they can go all the way up to millions, but actually if they understand the procedural fluency, if I can add these numbers, then it doesn't really matter. So subtraction is exactly the same method. Well, it's not, it's taking away, but it's exactly the same format. So we go from the concrete to the pictorial to the abstract. So we start off with our concrete, we have our deans, they count out 86, then they're going to take away 1 1, take away 2 10s. What do we have left? When they're able to do that and they know which column they're taking away from, then we move them onto the pictorial. So it's something like this. So they've drawn their deans, or they have made them, but probably drawn them at this stage. They could have just drawn sticks and dots. This is a bit more of a fancy representation for you guys. But now we're going to take away 1 1. There it is, it's gone. I'm going to take away 2 10s. Goodbye. And then we're left with 5 1s and 6 10s. And that's kind of bridging that across. That's what it would look like. Then we would move them on from that. They could then put it into a written method. They could, but hopefully by this point, they've realized, well, actually, if I've got 6 1s and I'm taking away 1 1, I'm going to have 5. So I don't even need to put it into a written method, particularly because they could do that in their heads. They could do 6 take away 1. They can do 8 10s take away 2 10s. So they should be able to work that out without moving on to a written method, hopefully. If they did need to use one, then that's okay as well. Where they might need to use a written method could be something like this. So they've got 70 take away 18. And this is a little bit more tricky because now they have no ones in the ones column. So what they need to do is we use the vocabulary. They exchange 1 10 for 10 ones. So first they do this in the concrete and they say, oh no, I've got no ones, Miss Woods. And you'd say, well, you do have 7 10s and one of those 10s can become 10 ones. So they move it into their ones column. And then they're like, oh, okay, I can take my 8 1s away now. And then they can take away their 1 10. So in the concrete, it would be like this. In the abstract, they're exchanging 1 10 for 10 1s. And it looks like this. So then I would have 2 1s and I have 5 1s. I think on the next slide, no, that's a shame. I would show you exactly what that needs to look like with the deans. But I think by this point, they're able to articulate, well, this isn't 7 because I can exchange my 70, 7 10s. One of them can become 10 1s. So it looks something like this. Okay, so what strategies do we teach for subtraction further up? Now I'm going to have a go at modeling this one, which might be absolutely hilarious. So I'm going to stop sharing my screen, hopefully. Sorry, I'm just going to check the chat quickly just to make sure there's nothing that's happening. Hopefully the person whose volume wasn't down is fixed. You just need to turn your volume up. Year 4 maths, all of it is kind of embedded in together. They're all kind of similar strategies. So I'm just going to share my screen so you can see a whiteboard. Now I'm going to try and write with this. It's not the easiest because it's a touchpad. So my question was, I had 20, oh my goodness, this is harder than I thought. I practiced this earlier. Okay, so the first thing I need to do actually, before I even write my numbers, I need to count how many digits do I have. I've got 1, 2, 3, 4, 5, 6. So I've got a 6-digit number. So I've got my 1s, I've got my, okay, right, that doesn't work. 1 second. 1s, 10s, 100s. Oh, I need a mouse. This is going to be difficult without squares as well. Thousands. Oh my goodness, it's easier than PowerPoint. 10,000s. Okay, 1, 2, 3, 4, 5. And then I have my 100,000s. Okay, I don't think this is actually going to work. I did try this earlier and Zoom is worse than PowerPoint. Okay, right. So my digits, I'm going to put my 7 1s in, and then I've got my 9 10s. It's going to come across. It's like I'm a baby writing. 800s, there's my 8. 4 to thousands, and I would use this vocabulary with the children. 3 10,000s, and then I have 200,000s. My sum is subtraction, so my subtraction sign is going to go in here. This is the worst thing I've ever modeled. Then I've got 6 1s, I've got 9 10s, I've got 900s, then I've got 5,000s, and I've got 4 10,000s. And you might say to me, why are you putting your digits in backwards? That's really, really key, because otherwise my 4 might have gone in this column. And if my 4 goes in this column and all my digits are out of place, then it won't be as I need it to be. Then I'm going to draw my big equals using my ruler in my book. Okay, right, now I'm ready to take away. I've got 7 ones, and I'm going to take away 6 ones, which is going to give me 1 1. I've got 9 tens, take away 9 tens, which gives me 0 tens. I've got 8 hundreds, take away 9 hundreds. I can't do that because I only have 8 hundreds. So I am going to take 4 10,000s is going to become 3, and my 1 10,000 is going to become 10 hundreds. So now I've got 18 of those things called hundreds. Well, 18 take away 9 is 9. That's a number complement I know, because that's half. Then I've got 3,000 take away 5,000. I can't do that either. So I'm going to have my 2 10,000s goes up here, and this is going to be my 1 10,000 is going to become 1,000 in there. So now I've got 13 take away 5. Oh, that's not one I'm too sure of. So I could put it in my head and count back. 13, 12, 11, 10, 9, 8. If I'm not sure, I can use my fingers, but hopefully in year 1 and 2, I've learned really, really carefully how to do 13 take away 5. Then I've got my 2 10,000s take away 4 10,000s, which I can't do. So this is going to become my 100,000. Then I've got my 12 10,000s take away 4 10,000s, which gives me 8. And then I've got 100,000 left. And that is the messiest working out I've ever done. And if it's right, I'm going to be very, very surprised. At this point, children may want to put a comma in. I really encourage them not to, because if I put a comma in like this, and then I copy that across into my answer box, which looks like this, a very old rectangle, they could copy it across wrong. And they've done all that hard work, and this is a 2 marker, and then they would still only get 1 mark because they've written their answer wrong. So no commas in our place value chart. If you want to put them in, they can put them in up here, because the thousands column is where we take a breath. So 188,901. Okay, I've learned never to do that again. Right, I'm going to share my screen back to my PowerPoint. Okay, and hopefully the answer was right. I was told that's going to be embarrassing. There we go. Right, so, and that's as hard as it gets. It really doesn't get much harder than that. And if the children are able to do that confidently, then even from, year 2 upwards, if they're taught, the structure of how to do it here, it doesn't make any difference, really. It doesn't matter what column it's in. Okay, multiplication and division. Times tables, that's all I can say about that. This number 14 is really tricky. 2 times 0 always tricks children out. They want to write 2. So the 0 times table is a thing. So please make sure you're covering that with your children. Because it always tricks children out every year, and it makes me so upset as I'm walking around and listening to them in class, and they'd always start with 2 4 6, always start from 0 2 4 6. What does that look like as we move through? This is how far it gets. 24 times 3, really simple. I do 4 times 3, which makes 12, and 3 times 20, and then add them together. Or I could go into a written method, or I could just know, perhaps some children at this point would know, I could do 25 times 3, which gives me 75, and then take away a set. It completely doesn't matter at this point, because they're so fluent with their number facts. And they probably know their 24 times table, to be honest, because we've drilled them so much with times tables. It does get a little bit more complex, of course it does. And I'm not going to go into this too much detail now, because this is more kind of year 5 and year 6 content heavy. So I will be doing another workshop where we'll go into this. The main thing is, if I just show you quickly, they times the ones first. So 4 times 3, which gives us 12. Then we do 3 times 5, which gives us 15, and we're still looking at those place value columns. The things that will struggle when you're timesing by the 23, when it's the 2's turn, it's not 2, it's 20. So I always say to my year 6s, we tick off our 1s and we block out for our 10s. And that's why we have a 0 here in the 1080 underneath. And that 0 is so important, because you're not timesing by 2. It's not 2 times 4, it's 20 times 4 and 20 times 5. Which the children can struggle with. And something that helps them with that is still using their place value heading. So my example didn't have that in the beginning, but I would definitely still have that and be using that language, because it's not 2, it's 2 10s. And the same again, you have to put your answer across into the box. But again, that's as hard as it gets. They might have a number in their hundreds column, but really, if they're really concrete with understanding what it means to multiply, the fact that that's 20, not 2, they can't really go wrong. So division, what does that look like? This, we spoke about division facts already. Division by 5, they learn to divide by 5 in year 2. All they do is make the numbers slightly larger. So for this, we would use short division. We would think, how many times does 5 go into 7? How many times does 5 go into 5? How many times does 5 go into 0? How many times does 5 go into 5? With the answer of 1501. And it's just a quick method, but now by this point they have a really concrete understanding. They could also check, they know that numbers divided by 5 always end with a 5 or a 0, so they're able to do that as well and be able to pull that apart and know what the answer needs to be. This is as hard as it gets. I'm definitely not going to talk you through long division today, but even within long division, they need to know their 13 times table. So in the year 6 SATs, I would get the children to write out their 13 times table. I've got 1 times 13, which is 13. I've got 10 times 13, which is 130. And it making them fill out all of those all the way up, then they're able to solve their long division, which is the hardest thing we'll teach. But actually, if they know their 13 times table and they're so confident, you know, with our place value headings, they're here again on this working out because they have to be, then they're able to solve more complex sums like this. Because they're really confident with their number facts, you know, they can do 13 plus 13 because I'm adding 3 1s and 1 10, 3 1s, 1 10. Here, I'm going to have to bridge, so I'm going to add another 10. And it's having that language and having that kind of understanding of what that needs to look like. And it's all what they learn in Key Stage 1. The basics, it's rehashed again in, you know, year 4 and year 5, but it is that solid understanding of number. We keep coming back to it, but it's so fundamental to everything. Fractions. So fractions are all about division. So they might recognize this fraction as being a third or 1 part out of 3. We teach it first with pictorials, or even cubes. I see 12. I'm going to put it into 3 equal parts. They share their cubes equally, 1 for you, 1 car for you, 1 car for you, 1 car for you, and they do it again until they're out of cars and they have 4 cars left. And that's how we teach it in year 1 and year 2. Then when we go into the kind of more pictorial, the more concrete, get my words right, the more abstract, they might say, well, I've got 21, I'm going to divide by the denominator and times by the numerator. So I've got 21 divided by 3, I know that's 7, 7 times 1 is 7. So they don't need the cubes then, they know that they're making a third. They don't need to share 21 with dots because they're really confident with 21 divided by 3 because fractions are division, they're out of a whole. For this one here, it's a non-unitary fraction because there are 3 parts out of 4, 3 quarters. So I've got 20, I'm going to put them into 4 equal parts into quarters. So 20 divided by 4 is 5, times 3 is 15. Or they may have recognized that if I'm finding a quarter, I half it and I half it again. It's using that shape knowledge. So half of 20 is 10, half of 10 is 5, times it by 3, you get 15. And that's all they really need to know in Key Stage 1 about fractions, is the fact that they're parts of a whole. You're dividing by the denominator and timesing by the numerator. And we would use that language with the children. We might say denominator because it's at the bottom and it's deep, and the numerator because it's the bit that's shaded and sparkly. But the language is the same. You know, we don't make it easier for the children. We still teach them those words and that vocabulary, but we show them it in the different concepts in different ways. So when we get to Key Stage 2, then this is one of the questions we could get. So they've got a different lay here. They need to know that 25% is equivalent to a quarter. I'm going to half 1,500 and then half it again to find a quarter. Or I'm going to divide it by 4 because that's the same as finding a quarter. But if they know what a quarter is and they know that they can put that into a fraction really easily, then this question isn't difficult anymore. They don't need to have any special knowledge. They know 25% is a quarter. They know that they're going to divide by 4 and times by 1, which will give them their answer. They also need to be able to add, subtract, multiply, and divide fractions in Key Stage 2. And that's introduced in year 4 and kind of readdressed lots of different times. to make the children really, really confident, but that's not something we're going to touch on today. But it's not something they learn in Key Stage 1, but it's definitely as we go through, how do we add fractions, how do we subtract, what does it mean to add, you know, and we're adding fractions, the largest number comes after the equals. We've learned that before when we looked at just whole numbers in year 1 and 2. When we subtract fractions, we have to start with our largest fraction first, and it's the same language and the same vocabulary, so key. If year 5 and year 6 and year 4 students could memorize this, our lives would be so much easier. Decimal fraction percentage equivalents, oh my goodness me. If they know that, if I'll give you an example here, if we go down to the first one, a decimal is 0.1, a fraction, that's 1/10, as a percentage, that's 10%. As an angle, that would be even better if they know that. But if they could just put this into their memory, like you'd learn number bonds in year 1 and year 2, if they could just know, if I say 4/5, you say 80%, and the amount of years of my life I've spent with my class doing ping pong of, I'm going to say 0.4, they're going to say 2/5 hours of my life I've spent doing that. So if you did want to go onto the website and get this off after and help your children learn these, it would be awesome. It really would. It would really help. Just so we're clear, at the bottom where it says 0.33 in the little dot, that means recurring. When we're talking about thirds, it's 33.3% or 0.33. Actually, the threes go on forever, but we round it up. We don't round it up, we round it to the same, which is 0.33. That's what the little dot means. Yeah, that would be really fantastic. And also looking where we have one whole here, 360 degrees, the idea that it's 5/5, 4/4, 9/9, that would be fantastic if they could memorize that. That would be really helpful. I'm nearly there, I promise. I know I've talked to you for, oh my goodness, nearly an hour. So what can you do to support at home? Support with times tables, including the 0 times table, number bonds, addition and subtraction facts. Just knowing them off by heart would be so helpful. Build their confidence. Ask them what strategies they're using. Talk about tens and ones. We used to call them units. Units are out now. We don't call them units anymore. We call them tens and ones. They might be blown away and be like, well, how do you know about your thousands column? That would be fantastic. Please try and stick to the strategies in school. The amount of times I've taught year 2 and the children come in like, but miss, I know a trick. And they show me column method and they're like, no, we don't need to draw our tens and ones anymore. And it can get them into a real pickle, because then they don't understand. They've got the number 101. They're like, but miss, I've got 0 tens. I can't do it. And I'm like, no, but you do. You have 10 tens because you have a 1 in your hundreds column. And if they're not really concrete on their understanding and they're moved on too quickly and they think it's a trick, you know, and a quick way of doing things, it doesn't help to deepen their understanding. And it does mean that sometimes misconceptions can get embedded really early. They'll move on when they're ready, and we will teach them procedural written methods, but there's so much value to be had in mental methods, and we do labor over them because they are so valuable. Some children will get tailored maths homework. So if they do get that, I've tried to make sure there's an example at the top so children know how we'd like it set out, making sure they're using their place value headings, they're using squared paper if you can. If you don't have squared paper, I understand you could, I don't know, get them to use plain paper is better than lined, just so they can line their digits up really carefully. Don't get them to draw squares though. Some of them will spend hours drawing squares. They don't need to do that. On the Effective Maths website, there's lots of resources for parents. That's there, the effectivemaths.com website you can download. And when I run some more workshops, please spread the word. I'm going to have to practice writing using the system to see how I can do this, because I've tried earlier with holding up paper and it doesn't work. So I'm going to have to think about how we can do this. Right, any questions that anybody has, please feel free to pop them into the chat for us. I know I've talked a lot at you today, and there's probably been an awful lot of information. Some of it you may have taken in, some of it might have gone completely over your head, but we will be recapping all of these strategies and helping you to understand, if you'd like to, at another point. And everything will be on the school website. Mr. Shepherd said we're going to put it on So I've also, from my old school, stolen a really great arithmetic SATs booklet, which I'm going to ask Mr. Shepherd if we can circulate, because it tells you how to solve long division and how to solve multiplication and things like that, which aren't easily explained using Zoom, but that's all in written form. So hopefully we can get that across. So if anybody else has any questions, and put them, please feel free to pop them in the chat. But thank you so much for everyone for coming today and listening to me go on and on for a whole hour. Hopefully you found the session helpful. Yeah, so me and my mum tried to log on to Effective Maths, but it didn't work. What are we supposed to do? So as I've said, it's very patented. They don't like us logging on, but there is a parent section. When you go onto the Effective Maths website, across the top, there is a little bit that says, I think learning from home or like parent area. And you can try and access some bits and bobs there. There are games and activities you can also do on Purple Mash. A brilliant multiplication check. You just log on, then you click on the maths section, and there are games and things that you can play as well on that. But Effective Maths are locked down, which is why you had my terrible representations today of drawing deans. And there isn't any way around that, I'm afraid, because of copyright. And the man who's made it wants to keep it all to himself, which is fair enough because it's a good scheme. Which ones do you want the answers to? I probably was rushing through and didn't give you all the answers. The PowerPoint will be on the website, as Sir has said, and you can listen to my voice again on the video as well. Yeah, if there's no more questions, or if anyone is, if you want to write them in, I'm going to unmute everybody so you can all say goodbye if you would like to. So if you can unmute yourselves if you'd like to say goodbye, and feel free to put anything else into the chat if you'd like. Right, I think everyone is becoming unmuted.
Goodbye. Thank you.
Thank you, Miss. Very informative.
Bye. Thank you. You're the best. Bye. Bye.
Okay, right. Thanks everybody for coming. Feel free to sign out. Have a lovely evening. Enjoy your rest of your, what day is it today? Wednesday. They're all blurring into one. Yeah. I'm going to go see what the puppy has done. I kind of want to show you the living room. Bye-bye, everybody.
Miss Wids, you're the best.
Thanks. Cheers. I dread to think what this dog has done. Right, I have to go. Oh, wait 1 second. We are in isolation at the moment. I would really appreciate it if I could have the breakdown of the strategies for year 6. Yeah, definitely. I dug it out today, so I could recap myself on bits and bobs. I will send you that home. I'll make sure that it gets emailed out because it's honestly such a good resource. I'm just going to steal it from him. I'm sure he won't mind. Yeah, and I think just to work on those strategies would be so helpful. And it really is fantastic. Right, I think that's all the questions. So I'm going to go and find out what this puppy has done. See you later, everybody.